Hello, and welcome to my talk on natural language generation in e-commerce. My name is Michael Sollami. I'm a lead data scientist at the Salesforce Commerce Cloud on the Einstein team. But before I begin, I just want to give a quick reminder that Salesforce is a publicly traded company and that customers should base their purchasing decisions on products and services that are currently available. We'll start with a brief refresher on natural language generation concepts, talk about what's out there in terms of state of the art, and we'll present an architecture called Mantis that gives a multimodal treatment of natural language generation. We will discuss some applications to retail and marketing, and then show some experimental results, and finally give a brief demo. You can think of most natural language tasks as learning a function from sequences to something. In these tasks, the order of the sequential items matter, and you don't know the length at train or inference time. For example, classification, that's mapping sequences of tokens to class labels, whether they sentiment or topics, distribution over a set of keywords. You have annotation, which is also known as tagging. This is really just mapping sequences to sequences of class labels, part of speech tagging. Parsing maps sequences to graphs, but these are all sort of classic applications, and really commonly NLP is just an umbrella term to include NLU, natural language understanding, and dialogue management and natural language generation, NLG. So NLG, it's the job to form an appropriate response, or to formulate text that looks human readable from some sequential input. Examples being OCR, speech recognition, reading comprehension tasks, and so on. Since their introduction, transformers have become the model of choice for virtually all NLG problems. They have a number of advantages, and they're easy to parallelize, so you can run them on really large data sets, and that has led to the emergence of these pre-trained systems such as BERT, GPT, or Control. They're all based on the same idea, this self-attention mechanism, which you can see in this figure to the left. Basically, you're trying to translate a sentence from English to French and back, and you realize that the order of the adjectives is important. And so in order to translate the sentence correctly, you need to pay attention to multiple tokens at the same time. And so the latest version of this is called GPT-3. It hasn't been released, but it's really cool. We're going to talk about that. The caveat being that all of these are limited to just textual tasks. Take a look at this plot from the OpenAI paper on GPT-3 in May. It's astounding that their model achieves near human performance at around 100 billion parameters in terms of accuracy on this co-QA data set. It's some sort of free-form conversational question-answer set. And this has been possible before, but only with very highly tuned, specifically trained models for this task. But this is a general model that can be applied to it and still come close to few-shot human accuracy. Amazing. Another example of what the model is capable of. Take a second and let these results sink in. It's very impressive. It remains unclear how cherry-picked those GPT-3 demos are. And while they're impressive, they speak to the power of the underlying language model. I want to talk about some specific applications of NLG to retail that we know we can control and we know we can do with high levels of fidelity and reproducibility. Two of those are writing assistants and human-computer interaction design generation systems. In order to build an AI writing system, there's a few things we need. So first off, pre-trained transformer models are they're very sensitive to large parameter changes during training and tuning. They're often very noisy and unconditioned for industrial use cases. That's why we introduced the control architecture from Salesforce Research. Unfortunately, control still works only on text, and there's no widely available data set that, at least for the e-commerce setting, that deals with multimodal language tasks. So really, although we have some great ideas in literature on how to combine modalities for doing certain tasks like classification or training specific types of embeddings, the existing systems that we have today are really just not good enough for commercial use. And so we took the ideas from the literature and pushed them a bit and came up with a solution. And the target problem is modeling the language of products. So what is that? Well, when you're writing copy, that is textual descriptions of products, this requires a non-trivial level of effort. You need to spark the imagination of people, using active verbs, explaining how the product solves certain problems, giving justification and sort of appealing to your reader's imagination. As you can see, there's a huge difference between these two descriptions. And this takes a lot of effort and time, and so it's expensive. Well, we thought, taking the state of the art in NLG, what could we do to automate the creation of product catalogs? And this was the motivational question, and the answer was the Mantis neural network architecture. That stands for Multimodal Conditional Text Synthesis. It's named for the mantis shrimp, as you can see. So its backbone is GPT-2, the large version, because that's what we could fit on our servers. But in the future, we could hot swap it in for GPT-3. So when trained on the product description task, the Mantis architecture would take tuples of inputs of different type. So it will take, for example, a set of images of a product, as well as its name as a string, and then a set of attributes, which could be of, again, strings or other types of metadata. And the idea is to treat the additional modalities as simply as word tokens. So we'll have text tokens and image tokens and audio tokens and other tokens. And we let the transformer learn at a high level how to handle the different modalities. So we don't need to do any sort of exotic network surgery in combining the different base networks. So this is what we've built. It's called Mantis, and it has a ResNet for the image tokens that we fully backprop through. We one hot encode into a linear layer, other categorical attributes such as um, the company or the vertical or the product type. And then everything works as normal. We use positional encodings and standard decoder transformers. We tested the model on the facade dataset, which was recently released in the accompanying paper, Fashion Captioning Towards Generating Accurate Descriptions with Semantic Rewards. And our model had higher blue scores on the holdouts than the other standard approaches that you can use. Here are some sample results. So the model is given the input image you see on the left and the name of the product, and it generates this paragraph. I've highlighted in green the interesting words, some of the words that it picks out from information that's only available in the image. And it's one of my favorite examples. The perfect addition to your home. Really, really sells it. Here's another example. It knows different types of clothing. It has an understanding of grammar, and it knows how to add flowery text that can really pass as human written text. So this is an interesting example. Basically, you had to zoom in on the image to see that there wasn't actually a fringe. When I looked at it, it was low resolution, and the model found that. You wouldn't know from the name of the product. Again, it'll start picking up things like detachability of hoods, breathability of material. It'll know like seasonality of items. Yeah, so some really, really fun stuff. And another great example of this shoe, basically you can't tell because of the resolution and the angle that there's a zipper fastening at the back of the shoe, but the model could. So that was rather impressive. It also got the low-level textual details right. So now I want to show a demo application using the trained mantis net in the form of an autocompleter. So here I'm in a Jupyter notebook and I'm writing text manually, and as I click tab on my keyboard, there is a response coming from the network that sort of guides the next phrases, the next sentences, and you can tab complete. Again, we're conditioning the input based on, here in this case, just the text being the name of the product on the left. So in conclusion, I'd like to thank my co-author, Ashish. Please be on the lookout for our forthcoming paper on our simple but effective approach to adding modalities for natural language generation. I hope that I've covered some really exciting applications and hopefully given you a brief but interesting look at this technology and what it can do in the near term. So yeah, thanks for listening. And if you'd like to reach me, I'm Sollami.ai or at msollami at Twitter. Thank you.